two variables. And your I can statement for today, we just have one. I can solve a linear inequality by graphing. All right, so we have solved linear inequalities algebraically before. It's the same way as solving an equation, except for when you multiply or divide by a negative. Remember, you have to flip the sign. And so graphing a linear inequality, we're going to see some similarities to graphing these, just like when we graph equations, but there are a little bit of differences. So some vocabulary you want to know for today: linear inequality in two variables. That's what we're working with. It's like a linear equation in two variables, but with an inequality symbol instead of an equal sign. The solution is a shaded half plane bounded by either a solid line or a dashed line. Okay, so the differences here are we're shading when we graph, and also sometimes our line might have dashes in it instead of being a solid line. The inequality symbol replaces the equal sign, so we have less than, greater than, less than or equal to, greater than or equal to. Those are inequality signs that you're going to see. A boundary line, okay, so this boundary line that's either solid or dashed, it divides the coordinate plane into two half planes. It can be solid or dashed. And this is the basic breakdown of everything we're doing today. So the type of line when we're graphing a linear inequality could be dashed or solid. This is our boundary line. It's one of the two. The one you're used to is a solid line when you graph. All right, and if the symbol that we have in our inequality is a less than or equal to sign or a greater than or equal to sign, then we're going to have a solid line because it includes that equal to part. Okay, so you can remember that if it includes part of the equal sign, then we're going to use the solid line like we usually do when we graph a linear equation with an equal sign. If we don't have any part of the equal sign and we have just the less than or the greater than symbol, this is when we're going to use a dashed line when we graph, okay, because it's not including that equal sign or equal to, so we can't include it. So it's dashed to show that we don't include it. It's kind of like when you graph as an inequality without two variables and you have an open circle versus a closed circle. We use the closed circle to show greater than or equal to, less than or equal to. We use the open circle to show less than or greater than because it's not including that value. Same thing here. So the dashed line is like an open circle. Solid line is like a closed circle. And then where to shade. So this is different because we're going to shade half of our graph. And so we're going to have 4 different possibilities because we have 4 different inequality symbols. If y is less than, or y is less than or equal to. So these are in slope-intercept form, except with an inequality sign instead of the equal sign. So y is less than or equal to. So we're talking about less, all right? So if you think about the y-axis, where the numbers are smaller, they're getting less, it's below. So we would shade under our line when you have the less than or equal to symbol. The other scenario is y is greater than mx plus b, or y is greater than or equal to mx plus b. And here, y is bigger, greater than. So you think about the y-axis, you're shading above the line. Where does y increase and get larger? All right, so we're going to try one of these problems right now. This is an interactive slide for you. It's a drag the icon slide, and I'm going to give you 2 minutes to do this. It says, which graph represents y is less than or equal to negative 1/3 x plus 2. Okay, I am going to put you on student pace right now just so you can go back and look at what we just looked at about those rules. And you have 2 minutes to okay. So we're going to take a look at what you came up with. And so we have stars all over the place. All right, so when you're trying to figure out which of these match the situation, I'm going to turn off student pace for a second here. And I'm going to go back to the rules, okay, because I'm going to look first at, is this in slope-intercept form, but with an inequality sign? Y is by itself on its left. That's true. And then I have the x term, and then I have the constant. So this is slope-intercept form. It's ready to graph, just like if I was graphing an equation. And I know something about the symbol, right? And so if I forgot, I could come back here. Let's see, less than or equal to, I know that's going to be a solid line. And also, I know that it should be shaded underneath. All right, so let's come back here. So which of these is a solid line? Well, all four of them are solid lines, so that doesn't really help. Which ones are shaded underneath? Well, A is a possibility. B is a possibility because where the line is, I'm shading below it. But C and D are not going to work. So it's not C and it's not D. So if you have your star on C or D, you should move it to either A or B. Next, we can look at how we would graph. Okay, when you graph an equation in slope-intercept form, we always plot that y-intercept first, +2. So do these graphs have lines going through +2? I have so many stars, I can't tell. So right here, this is passing through +2, and this is passing through +2. So that doesn't help narrow it down. So what I'm going to have to look at is the slope, -1/3. And if I look at these two slopes, well, on A, this is a negative slope. It's going downhill. B is a positive slope. It's going uphill. So I don't even have to count to see which slope is -1/3. The only option here is A. A is the correct answer in this situation. All right, so A is our graph, and we're going to try another one of these. So I'm going to put you on to the next problem, y minus 2x is less than 3. And you're going to try to figure this out, but you may notice that this is not in slope-intercept form yet. So we have to think about how we can change that to slope-intercept form. If this was an equation, and I was trying to change it to slope-intercept form, how would you do that? You have to do something with this minus 2x term, okay? And so I am going to give you 2 minutes again to try this. So I'm going to share with you your responses. I got 12 of you to respond. Don't be afraid to make a mistake, all right? Because I can't tell what you're thinking unless you try. All right, so this is interesting. We have choices on A, B, D. Nobody picks C. So if I look at what I have here, it's not really set up into slope-intercept form. So I added a Jamboard that I'm going to present to you. You don't necessarily have to open it right now. You can just see it because I'm presenting it to you on my screen. And what we're going to do is take this and put it into graphable form, which means I want to get this 2x term onto the other side. So I'm going to go ahead and add the opposite and do the same thing over here. And then I can rewrite my form, or my equation, I'm sorry, as y is less than, and then that 2x and the 3, they're not like terms, so we're just going to put them next to each other in slope-intercept form, where I write the x term first, and then the constant after that. Okay, so this is what we're going to be graphing. Y is less than 2x plus 3. And so I'm going to come back to our presentation. Y is less than 2x plus 3. So there's lots of things to check. I could look for which graph crosses at 3, which graph has a slope of +2, which one has the right line, a dashed line or a solid line, which one's shaded the right way. There's all these different things that you can check for to narrow it down. If I come back to the rules, okay, less than means it's dashed. So I need a dashed line, definitely a dashed line. And less than means I'm shading under. So a dashed line where I shade under, well, it's either C or B because they have dashed lines. C I'm a shading above, so it can't be C. Therefore, the only choice is B. B is your correct answer. All right, so everyone should have their star on B, and we can kind of check too that this crosses the y-axis at +3, and the slope is in fact +2, because if I rise 2 units and run 1, rise over run, 2 over 1, that's +2. I can reverse it, go down 2 and to the left 1, down 2 to the left 1, down 2 to the left 1. So B is your correct answer for this slide. We're going to do one more of these together. Okay, this one you're going to have to rewrite it. It's a little trickier, so you're going to have to do something different to get it in slope-intercept form. Notice that the coefficient of your y term here is not 1, it's 3. So think about, how do we change an equation or an inequality so that y is isolated? What should I do to every term? I'm going to give you 2 minutes to work on this one as well. Okay. So go ahead and come back to our Google Meet. And here's the one that I just had you working on right now. And so if I show your responses, we have stars all over the place, which is okay because we're learning right now. So let's kind of take a look at this inequality and how we can rewrite it so it's graphable, and then maybe you'll want to change your star location. So in your Google Meet right now, I'm presenting to you the Jamboard. And this is the equation, 3y, I'm sorry, this is the inequality. 3y is greater than 3x plus 9. So to get y isolated, I am going to divide by 3, because 3 divided by 3 is 1, and then if my coefficient of my y is 1, that means y is isolated. But when I divide one side of the inequality by 3, I need to make sure I divide every term on the other side also by 3. So this is going to simplify this into y is greater than x, because 3 divided by 3 is 1, so just 1x. And then I'm adding 9 divided by 3 is 3. Okay, so this is actually what I'm graphing. And if you don't see a coefficient in front of your x term, I could put it there. It's a 1. If I'm thinking about graphing a slope of +1, you think of that as 1 over 1. All right, so this is really what I'm trying to do. Y is greater than 1x plus 3. So maybe you might want to change where your star is over here. Y is greater than x plus 3. One way to approach this problem is look for the line where y is equal to x plus 3. Which of these graphs has that line graphed? Because only one of them has that line actually graphed. The greater than part, that's going to tell us that the line is in fact dashed. Okay, so if your star is on A or D right now, and I'm going to make you go to this slide if you were on a different slide. So I just turned off student paste. Everyone's on the same slide. You should not have a star on A. You should not have a star on D, because this symbol means I have a dashed line, right? So if your star is over here on A, 2 people, you want to move it to either C or B. I'm just trying to figure out now from C and B which graph is y is greater than 1x plus 3. I'm going to hide your stars for a sec. And so I know my graph has to cross through +3. It happens here. It crosses at +3. It crosses at +3 here. The slopes are slightly different. I could count the slopes to see which one is 1. Or y is greater than x plus 3. So that means I have to shade above. So which of these is shaded above? C. Everyone should be on C. The correct answer is C. Move your star to C. Okay. So coming back to our lesson, I'm going to show you some examples. And let's see. Yes, I don't want you in student pace right now. I'll put you back in that in a second, actually in a few minutes. But when you're graphing a linear inequality, you want to think about first graphing the equals line. So just imagine what would the graph look like if it was an equal sign. And that's kind of what we were doing in those first three problems. We were rearranging it into slope-intercept form so that we can see what the graph would look like. Okay, so you shade the correct area after that. And you could think of it as 3 steps. Step 1, rearrange the equation so y is on the left and everything else is on the right. So it looks like slope-intercept form, except with an inequality. Step 2, plot the y equals line, all right? Sometimes that line will be solid and sometimes it will have dashes. You can make a solid line if you're doing this by hand and then go back and erase to make the dashes if you need them there. For on here, we're going to plot a couple lines. You can do the same thing. You can graph a line with the line tool and then use the eraser tool to just make dashes in it if you need it. And the way you tell is that it's solid when you have these 2 symbols and it's dashed when you have these 2 symbols. Okay? Now, after that, the last step you're going to do is you're going to shade above the line for a greater than symbol, because y is greater than. We're showing everywhere y is greater than, so you would shade above. And then the opposite would be to shade below with the less than symbols, okay? Less than or equal to. All right, so this is what we're going to do, these 3 steps. I'm going to show you some examples, and then you're going to try this. So here's our first example I want you to take a look at. Graph y is less than or equal to 2x minus 1. Step 1, we don't even have to do anything. Y is already on the left and everything else is on the right. Step 1's done. Step 2, plot y equals 2x minus 1. Okay, so we're thinking about it as if it had an equal sign. And it's going to be solid because of that symbol, okay? The less than or equal to includes an equal to, so it is a solid line. And that graph, this is just graphing in slope-intercept form. You plot your y-intercept, which is -1, and then you use your slope to plot more points. You rise 2 units, you run 1, make a dot. Rise 2 units, run 1, make a point. Repeat. Okay, so that's the graph. And then the last step is to shade. So you're only going to shade one side. You shade the area below because of the symbol you have. Because y is less than or equal to, we're shading everywhere below. And this is the final picture here in this pink outline box. That's what it looks like. Let's look at another example. 2y minus x is less than or equal to 6. So step 1, we actually have to do this time. We need to rearrange this so it is in slope-intercept form. We do that by adding x to both sides. And then we get 2y is less than or equal to x plus 6. Isolate y by dividing everything by 2. You've done a lot of this type of rearranging. We've done this in Delta Math when you're taking standard form and putting it into slope-intercept form. Okay, this is something you've had a lot of practice with. It's just the symbol is different now. And then rewriting it. So this is our equation. After you know the equation, step 2, you're going to plot that line, paying attention to the symbol. The symbol tells you if it's solid or dashed. This symbol means it's solid. The line starts at +3 on the y-axis. The slope is 1/2, so I rise 1, run 2. Rise 1, run 2. Step 3, shade. Because it's a less than or equal to symbol, we shade where y is less than the lower half. One more example to look at, and then you're going to try a couple of these. So graphing 1/2 y plus 2 is greater than x. Step one we need to do, we need to rearrange it so it looks like slope-intercept form. So if I'm starting with 1/2 y plus 2 is greater than x, I'm going to first get this constant term to the other side by subtracting 2 from both sides. And then to eliminate the coefficient in front of the y that is not 1, you can multiply by 2, because 2 times 1/2 is 1. And remember, that's what you're ultimately trying to get, is a 1 as your coefficient in front of the y. That's how you know it's by itself. But if I multiply the left by 2, I need to multiply the right side by 2, and that would be the distributive property over here. 2 times x is 2x, and 2 times 2 is 4. Now that this is in slope-intercept form, we're going to plot y equals 2x minus 4. So I go to -4 on this graph, which you can't really see. And then from there, you're going to rise 2, run 1, rise 2, run 1. And this is a dash line finally, because it doesn't have that little half of an equal sign there. So whenever you have the greater than or the less than, it's a dash line. And if you're doing this in Pear Deck, you're going to make a regular line with the line tool, and then use the eraser tool to go back and make dashes in it. Step 3, we're going to shade. Well, it's a greater than symbol, so where is y greater than? It's all the y values that are greater than, so we shade above. Okay, so you have 2 that you're going to work on, which is slide 11 and slide 12. I'm going to give you 10 minutes to do this. You are in student paste mode. You're going to go to your Pear Deck tab. So go ahead and I'm going to stop student paste. And I want you to come back to our Google Meet. So you just pause on what you're working on right now, come back to our Google Meet. And if I show some responses here, there's some people that got pretty close. So like right here, they started at 4 and then they went up 1 over 2. So they got the correct equals to line, but then because this is an inequality, we have to take it to the next step. All right, and so the way we're going to do that is, okay, so here's one. I'm going to start by plotting +4 right here, and then I'm going to use the slope to plot more lines, so more points, I'm sorry, up 1 over 2, up 1 over 2, up 1 over 2. Once you have enough points, you then create a line. Okay, I'm going to use a thinner line because I don't want it to be. Okay, and you always want to put those arrows at the end of your line. Doesn't matter if it's dashed or solid, we're going to have arrows. And in this case, because we have the less than symbol, this is going to be one of those dashed lines. So then I'm going to come through and I'm going to erase parts of it. Okay, because it's less than, it doesn't include the line. And maybe I'll use the highlighter to shade the side I want. You can use any color. I'm going to use green. Less than, well, where's y less than? It's over here. Okay, so that's how you do that one. Coming back to our presentation slide, slide 12, we did not, I didn't find anyone that got this one correct as far as getting correct responses. It may have not been enough time for you to try this one, so I'm going to show you how to do it right now. We're going to first plot the y-intercept, which is -5, because this is set up in slope-intercept form, so that's going to be right down here. And then I'm going to plot more points to represent my slope of -3. Now, my slope of -3, if I want to think of it as rise over run, remember, if it's a whole number or integer, you just need to turn it into a fraction, so you have rise over run. And now I can plot points using that rise over run slope. So up 3, 1, 2, 3, and then run 1 in the negative direction because I want to go downhill. Make that a little larger. And then we repeat up 3 over 1, up 3 over 1. You can do this as much as you want, but once you have enough points, you're going to connect it with a line. And then put arrows. Okay, so step 1 that we had was get in slope-intercept form. It's already there. Step 2, graph the actual line. Step 3, decide if it's solid or dashed. It includes the equal to, so we're going to leave it solid. And then we're going to shade it in the last step. So y is less than or equal to. So look at where it crosses the y-axis. Where is y less than? I have to go down. I am shading on this side. Okay. So that is the end of our lesson today. There will be a video up shortly. I am going to put you back into student pace mode. So you should go back and adjust your slides now to match what we did together for 11 and for 12. And you can use the video to go back and check on these as well. But that's it for today. So if you want to stay on the meet and ask a question, you can. Otherwise, it's 11:40 any second now, and you are free to go. Thank you, guys. Have a good rest of your day.